Plexus is a 3D particle system that helps you to create organic structures and networks. Now, imagine a 3D particle system where points are scattered in 3D space. Unlike other particle systems, Plexus creates connections between particles that are closer to each other. Now, let's consider 2 points that are separated by a certain distance. Now, as you can see, these 2 points are connected by a certain line, and it's a solid line. Now, as they move away from each other, as the distance between them increases, the line gradually fades out to zero. And again, when they gradually come closer, the line between them gradually becomes a solid line. This is the fundamental idea behind Plexus. Not only that, Plexus has a unique modular workflow where uh, that makes it completely dynamic. You can have infinite set of configurations, and the key to Plexus is it's not a single effect to control everything. Plexus is a set of multiple effects that work in conjunction to produce the final result. Hi, this is Sathya Maker. Today I'll show you how Plexus works. Let me create a new comp. Let me create a new solid. And to apply Plexus, go to Effect, Row Byte, Plexus. Now you see Plexus automatically applies two effects here. One is Plexus and the other one is Plexus Toolkit. The toolkit is nothing, its only function is to add new objects and new effectors. It does nothing but to add new objects and new effectors. So, and the Plexus mostly has all the rendering controls and blending options and stuff. So let me go ahead and create a new object. Let me create a path object. And as the name implies, path objects are they take the paths from the layer to create the particles in Plexus. So let me go ahead and create new path. As you can see, it already creates a Plexus here with all the points and lines. And you have many options here with the path object. Mainly, you can control which mask to be considered. You can control the which mask to be considered by the name of the mask. Yeah, I can put it to say a custom name called path, and only masks that begin with the name path are considered. Let me rename this to path, and let me purge. Okay, now you see only the masks with the name path are taken into consideration. And in the same way, you can subdivide the mask if you want. If you don't subdivide, only the original points in the mask are taken into consideration. The original vertices of the mask are these points, and only those are considered. But if you subdivide them, they're subdivided into additional number of points, which can be controlled by the points on each mask. You can decrease them or increase them. The more you have, the bigger the number is, the more number of points you have. And the next one is get path from text. Say if you have, let me disable this layer. Say if you have a text layer called Plexus. Anything, any text. And if you apply Plexus to it and add a path object, so when this is selected, the get path from text is selected, it automatically converts the text outlines into paths and creates the Plexus from it. It can be really useful if you have a lot of text objects, so you don't need to convert every text layer into mask manually, so this saves a lot of time. And let me delete this. Okay. And now I have the get color from mask. If you select this, the color of the mask, which in case here is pink, is taken into consideration. Now you can change it to anything you want, say orange or anything. But to actively see the change, because After Effects doesn't actively report the changes of the mask color to the effect, so all you have to do is purge once and you see the changes. If you don't want the color from the mask, just deselect this option and you'll have back to normal color again. And in the same way, you can get the opacity from mask. If you select this, the opacity of a mask can be controlled here, mask opacity. So you can control the opacity from the mask too. Let me deselect this, and this is if you don't have the color from mask and opacity from mask, you can change the color using this option here. You can change the color to anything you want, the opacity, and other stuff. And now here I have replication. Replication is actually it creates multiple instances of this object you have here within the same object. So let me show it to you by increasing the number of copies. Now, as you can see, you have a multiple number of masks within the same object, and you can control the depth of extrusion. You can make those instances distribute over a certain depth, and you can control that using extrusion depth. And let me switch to points for right now, so it's more, yeah. And actually, it's not that bad. And you can also have uh, a rotation gradient from the beginning to the end. I mean, you can have a rotation that changes from the start to the end. Say, in the start you have a certain angle, and in the end you can have a different angle. So the rotation gradually changes from the start to the end. Let me put this back to 0 for right now. And let me create a camera. If you're not aware, Plexus is completely camera aware. So you can navigate using the 3D camera in After Effects. So, okay. Now, with the replication, you can rotate the starting and the ending instances. You can control the rotation that goes to the start to the end of the instances. Just really self-explanatory. So that's the rotation. You have X rotation, Y rotation, and Z rotation. And now the groups. Groups which will go into uh, more detail when we talk about effectors, but groups basically these points, they belong to a certain group. That's what group is about. We'll talk. You can change its group. You can put to group 2, group 3, or any group. We'll talk about groups in detail when we talk about the effectors and the rendering. Thanks. Now let's see how the light objects work. To add light object, go to Object, Light, and to as you can see right now, you gotta have some kind of point lights in the composition. So let me create a new light and call it Plexus. You can call it anything, Plexus. You see a little point in the composition. Let me increase the point size so I can see it clearly. Okay, and you can have any number of lights you want. And Plexus automatically creates the connections between them based on the settings. Now, coming to the light objects, you can control which lights to be considered by the light object. Right now, all lights are considered. You can change it to a certain light whose name begins with light. Right now, all the point lights, they begin with the name Plexus, so none of these point lights are considered. You can change it to Plexus, and all of the point lights are considered. You can also have custom names, say something you want to have a custom name, something like points or something. Now only the lights that begin with the name points are considered. So if you create a new light, call it points, you see that light is considered. Let me delete this. Let me put back to all lights. So all lights in the composition irrespective of their name are considered. Now you can get the color from the lights. Say right now it is switched on, so you can go to light options and change the color to red, and you can see that that particle changes to red. If you don't want that, I can switch off get color from lights and have a single color to control all the points. And the same way, you can get the opacity from the intensity of the light. In the light options, you can control the opacity based on the intensity. Intensity is nothing but the opacity in this case. So 0 intensity is 0 and 100 is complete opacity. Now, if you don't want that, you can switch it off too by checking this off. So you can control opacity of all the points based on the opacity slider from here. Okay, now like in path objects, you have this replication controls where you can create multiple instances of this Plexus. So you can replicate in space. Let me create a new camera, and as you can see, you have multiple copies of the same thing. And you can rotate them, in certain order. You can have both X and Y rotations. It's just like path objects, and you have the control on rotation center. So there's a lot to play with, and you can create as many copies as you want. And as you can see, it looks really cool. If you're familiar with Cinema 4D's multiple Effector objects, kind of has the same sense to it. Actually looks really cool. And you can use cameras to rotate the scene, to zoom in. It is completely camera aware. And that's pretty much it coming to the light object and the groups. You can change the group, which group this object belongs to. You can change it to group 2, group 1, or anything. And that's pretty much the light objects. Now let's see how the OBJ objects work. So to create an OBJ object, go to Add Object, OBJ. Now you have to click on Import OBJ to and navigate through the File Open dialog and click on an OBJ file. Now, as you can see, this OBJ has a lot of vertices and stuff, so let me just create 2 points. Let me create a new camera. And, yeah. As you can see, the OBJ, let me increase the point size just a little bit so it's more prominent. Okay, as you can see, the OBJ is imported this is made in a 3D application, and you can use these OBJs to create a Plexus, and you can use all the effectors and stuff in After Effects. You can also load a sequence if selected. If the file is a part of sequence, all the files are loaded in alphabetical sequence in that folder. And you can also have different kind of loop. You can have normal, ping pong, or freeze. And the resolution, sometimes OBJs have a lot of vertices, like sometimes in millions, so it can decrease the resolution and to, like, say 20%, so only 20% of the vertices are actually considered and the rest of them are ignored. This is useful if you have like a really highly detailed object, which you don't need as much as millions of vertices. So this is really helpful if you use any stock models with a lot of vertices. Let me put it back to 100. And next you have the transform OBJ. Now OBJs, because they're made in different 3D programs, they have different scales, they have different locations, so this kind of helps you to control the location of the OBJ system. Right now I have a camera, so it's not accurate. Let me transform this. Okay, now see, kind of helps you to move the OBJ file to the location that's required, and you can scale them. You can make them small if you want, or you can make them big if you want. You can have individual controls for X, Y, and Z. If you deselect this, you can individually scale them. So you can let me switch back to points and lines. So as you can see, OBJs they look really nice when applied the Plexus in After Effects. Okay, let me switch back to points. And similarly, you can rotate them. X, Y, Z rotate, because sometimes OBJs have different rotation systems based on the 3D application. So this definitely helps to solve that problem. And you can change the color to red or anything you want. Change the opacity, and you can change the group they belong to. We'll get into groups in a little bit, but groups, you can have 10 groups. Now you can change to any group you want. So that's pretty much it for the OBJs, and we'll see effectors. Let's see how effectors work in Plexus. What exactly is an effector? An effector is something which can modify the position and the color of the points in the Plexus. It can modify either the position or the color or both. So to see that, let me create a new object. Let me create a mask, and let me create a new camera, and let me replicate this just a few times. Okay, now you have a basic rectangular Plexus, and let me add an effector called noise effector. Noise effector, as the name implies, it adds noise to the points. It adds changes the position of the points, so they scatter in 3D space. You can increase the amplitude, which actually adds the noise to the point. So the more the amplitude is, the more noise is applied to points. You can control the noise using the scale. So the bigger the scale is, the more detailed. The bigger the scale is, the more wide range of noise values you get. It's exactly how Pearly noise works. You can offset the noise values, or you can create an evolution, so the noise values evolve gradually. Say really, slowly or really. Let me switch to points so that I can create much better look. Okay. So the points gradually evolve. You can control the evolution rate. You can make them really fast or make them really slow. For right now, let me put the evolution back to 0. And you can apply the noise only to the x-axis if you want. So only the points in the x-axis are affected. And you can change this to y-axis. So only noise is applied only to y-axis. And you can have z-axis, or you can have xy, or you can have xyz. Okay. Now we can generate both positive and negative values. Right now we're generating both positive values and negative values. Now let me put this back to say 100. Now right now noise is applied to all the points in the plexus. What if you want noise to be applied only to a specific region? So that's when you have to use noise, lights for noise. When you click that, you see nothing happens because you need to have a point light in the composition. Let me call this noise. Now, as you see, only points in this region are affected by the noise. We change the amplitude, the amplitude of the noise applied changes, and if you change the intensity, the radius of the region increases. So more points are actually affected by the noise as the intensity of the light increases. That is, the radius of the region increases. Now you can change the name with which the noise effector lights begin with. Right now it's noise. You can change this to say force. So only lights that begin with the name force are affected. So to do that, let me create a new light, call it force. So only lights with the name force are affected. Now you can switch back to anything you want. Switch back to noise. So only this light is taken into consideration, the noise light, which has a bigger region. So by doing this, you can precisely control which region of the plexus you want to apply the effector to, and you can have specific regions with a certain effector, and you can create a lot of physical simulations with this property. It's pretty cool actually. And now the last one. You can control the noise seed, that random number, which controls the noise values. If you change the value, you get totally different noise values every time. So if you have multiple objects, you can change this, so you can get multiple different noise values for each object. Now, last but not the least, groups. So remember when we talked about groups in objects? Say for example, in this object, all the points made by this object belong to group 1, and this effector affects all the groups. Say if you change this to group 3, it only affects points in group 3, but in this object it belongs to group 1. So if you put it back to group 1, you can see the points are affected again. So what it does is effectors can affect only objects belong to a specific group, or they can affect all the groups. If you select all the groups, it affects, irrespective of which group this object is, all the points are still affected. But if you select this to a specific group, only points in that group are affected. So this can be really helpful if you have multiple objects in the same layer with multiple configurations. So that's really helpful if you have a lot of different configurations, a lot of different fields, a lot of different effectors. That's the primary purpose of groups, to actually have different kind of groups interact with each other. So that's pretty much the noise effector. Let's create a different effector. Let's go to spherical field. Now, as the name implies, it creates a field around the center of the field, around the center. So let me, if you increase the radius, you can see it creates a nice spherical field. And you can apply the field to x-axis only, or y-axis only, or z-axis. You can have a lot of control on which axis you want to apply. So this is great, but what if you want the field to be applied to a specific region? Say in the same way with noise effectors, you can control the spherical field with lights. So if you use lights, let me create a new light called field. You can see only in that region this field is applied. Now if you increase the intensity, the radius of the spherical field actually increases. So in this way you can control which you can have as many number of lights as you want, not just one. So you can control a wide variety of you can have a lot of different physical simulations and interactions with this setup here. And like every other effector, you can limit this effector to a specific group or apply it to all the groups. Say if you want to limit this to group 3, nothing happens because we don't have any group 3 objects here. We only have group 1. So switch back to group 1, you can see, or you can switch back to all the groups, so you can see it applied to all the objects irrespective of the group. So that's how the spherical field effectors work. Now let me delete this. Now you can have another effector called container. What exactly is a container? Well, a container is actually an effector where everything is locked into a container. Say, let me select cube. Everything is locked. Let me decrease the extrude depth. So, okay, here, everything is locked in this container of cube. You can increase the width, or you can increase the height. No matter what you apply. Say, let me apply noise. Now, when you apply noise here, as you can see, the noise is being applied because the order of the effectors is important. In this thing here, the containers are applied first and then the effectors. Now if you move this up, the noise is applied and then the containers are applied. So no matter how much you change the noise, the container locks all the points in a specific cubical container. And so the order of the effectors is also important. So say if you want the noise to be applied after the containers, all you gotta do is put back noise before, and you see noise is being applied after the containers. Say if you don't want to see the noise effectors at all, you can switch out the noise effector and you don't see the noise effector being applied. Right now, let me put back to the noise effector back. So container locks everything inside that cubical container. You can also have a spherical container sphere, so everything is locked in that sphere. It can be really cool if you have like say like evolution noise, and you can have like this multiple kind of like sphere gobbling thing, but like I can change the location of the container. So only you can change the location and you can decrease the radius of the sphere. Everything is self-explanatory, and like every other effector, you can only apply the containers to a specific group if you want. Say if you restrict it to group 3, only objects from group 3 are affected, but right now group 1. So all the objects in the group 1 are affected by the container effector. Or if you change to all the groups, irrespective of their group, all the objects in the plexus are affected by the container. So that's the container effector. Let me delete that. Let me delete the noise effector too. And the next one is transform. This is pretty self-explanatory. All it does is moves moves the plexus from moves the points and rotates and stuff. Now this might be useful if you have multiple objects and if you want to rotate only one group. Say if you want to rotate only group 3, so that only group 3 is affected, and the same way only group 1, so only group 1 is affected. So if you have multiple objects and if you want to move individual groups, you can select you can use the transform effector to move those groups and objects. So that's the transform effector. You have rotate and translate. And now the next effector is color map. What it does is it applies a color map to the plexus. To see how it happens, let me create a new solid and let me apply you can see there's a color map. Let me pre-compose this, call it a color map, and move all the attributes to the new composition and deselect this. Okay. Now if I apply the color map, see the color map is being applied to the plexus. You can flip the color map in horizontally, or you can flip it vertically so that they're inverted. And you can restrict the effector to a specific group if you want. Say group 3 or group 1 or anything, just like every other effector. So that's the color map for you. You can have multiple effectors, and you can say if you want to have noise after this, you can add noise to it and still the colors retain. And that's how the color map effector has worked. And let's see the next one. It's shade effector. So let me delete the color map. Okay. Shade effector actually shades the points in the plexus based on the lights, the point lights. Right now you don't have any shading lights. To create a shading light, all you gotta do is create a new light, call it color. You can change the name later if you want, and change the color. If you can see, there's a light dim, the points are dimly lit right now. Change it to red, and you can increase the radius of the shading, which is nothing but the intensity. So let me put back to 250. Now as you can see, as the thing moves, the points are shaded according to the position of the light. Now the advantage here is you can have multiple lights with multiple colors, and you can have a really good blended look, like a good shaded look in 3D space. This really helps to shade only a specific region in the plexus. So that's the shading effector. Now if you want to change the name, you can see shading name, shading light's name starts with color, or you can change it to tint. So only the lights that start with name tint are considered, or you can have a custom name, call it crayon or something. So only the lights that start with the name crayon are considered. So let me create a new light, call it crayon, and you can see only those lights are selected. Let me increase the intensity. So you can control which point lights to be considered for a specific effector based on the name of the light. And like every other effector, you can limit which group you can apply the shade effector to. Say if you want to apply to group 3, all the points in other groups are the same, but if you want to apply to group 1, which this object belongs to, you can see the shading is applied. Or you can also apply it to all the groups. So that's the basis of the effectors in Plexus. You can have as many effectors as you want. Say if you want to have noise and then container, add effector, container. Okay, now as you can see, the noise is applied first, and then the container is applied later. And if you want to change the order, all you got to do is put the container back up, and if you want to shade the particles after all the noise and containers, all you gotta do is put the shade effector to the bottom of the effect stack, and they're shaded accordingly. So the order of the effectors is very important in Plexus, and if you want to if you don't want to apply a specific effector, all you gotta do is switch off that effector, and that effector won't be applied. So this is the effectors in Plexus, and in the next thing we'll see the rendering options. Now let's see how the rendering controls work in Plexus. To apply Plexus, go to row by Plexus. Now let me add a new object, path object. Let me create a new thing, rectangular thing. Now you see you have a basic rectangular Plexus here. Now you can change the blending mode of the points and the lines, and you can change the settings of the various points here. Now we can increase the size of the points by increasing the size here. So the bigger the size is, the bigger the points are. And you can change the color. This thing is override points color. Now by default, objects have a certain color, which you can create. It can create red, or you can create anything you want. If you want to override this color, if you have multiple objects, and if you want to override all of the objects' colors, all you gotta do is check this override points color, and you can set the color here instead of in the objects. And if you switch this off, it defaults back to the object color. And the same goes to the opacity. If you select this, this opacity, it doesn't, it gets overridden by this opacity. So if you check this off, the opacity reverts back to the opacity of the object. And another important thing is points or perspective aware or not. If you have a camera, when you zoom in, the points get bigger. The points get bigger and bigger. That's being perspective aware. If you switch this off, irrespective of where the points are, they always have the same size. That's orthographic projection. So if you decrease, you put it back to 2, irrespective of where, how much you zoom into the points are always 2 pixels wide. Whereas if you have the perspective aware points, they become bigger when they become closer. Okay, let me reset this. So as you can see, the points become smaller and points become bigger as they come towards you. That's how the perspective aware works, and the same goes to lines too. And now we have the texture sprite. You can use kind of like sprites if you want. Instead of circular points, you can use say if you have a little sprite of 100 by 100, Actually, let's make this white. Okay, so let me put it in the bottom, select it, and change the texture sprite to white solid. Now you can see all of the points are replaced by the point sprites. But you can still change the color to whatever you want, and I can have it. So let me apply basic ramp. Okay. Now you have a radial ramp on this thing. You can let me pre-com this. Now you can see the points are actually applied by the points are actually placed by the sprite here, which in case is the ramp. It's going to be really useful if you want to use a custom particle instead of the default circle. For right now, let me switch back to none and see. Okay. So that's how the point rendering works. That's one reset. And let me delete this thing here. Okay, now let's go to the line settings. Now, maximum distance and fade out distance. To illustrate it better, let me create a light object. And let me create a new light and duplicate this light. Now, as you can see, the line initially is a solid line, and after a certain point it gradually fades out to zero. I'm not sure if you can see this. Let me increase the thickness of the line so it's more visible. Okay, thickness of the points too. So the line stays solid until a certain point, after which the lines gradually fade out to zero. Now this can be controlled by the maximum distance. So the maximum distance is the distance until which the line remains solid, and the fade out distance is the distance after the maximum distance through which the line gradually fades out to zero. So if you increase the maximum distance all the way to 100 and put the fade out distance to zero, as you can see, the line remains solid until the distance between them is less than 98 pixels. And as soon as it reaches 100, it completely fades out to zero because there is no fade out distance. Now if you increase the fade out distance a little bit, say to like another 50, so after it reaches 100, for another 50 pixels it gradually fades out to zero. So that's how the lines are calculated. And as usual, you can change the color of the line. So by default, the lines get the color from the points. So if you uncheck that, you can see you can have a different color just for the lines. And in the same way, lines get the opacity from the points too. So if you uncheck that and change the opacity, you can control the opacity of the lines individually. And thickness, and you can also switch off the perspective scaling of the lines if you want. So that's like the basic rendering controls of points and lines. Now you can draw only points, you can render only points, or you can render only lines, or you can render points and lines. This is quite useful if you're working on a project, and if you want to if you have a lot of complex objects and stuff, you can switch to points just when you're working, and when you're rendering you can switch to both points and lines, so the lines are rendered too. And draw lines between all groups or same group, different groups. Say suppose you have objects between different groups. This looks ugly, so Let me decrease the thickness line and okay, so right now I have two different objects and they both belong to group 1. So let me change the light object. Let me replicate that too a little bit. Let me change this to group 2. And right now lines are drawn between all the groups. Irrespective of their group, lines are drawn when the condition satisfies between them. So right now points are long lines are drawn between all the points irrespective of their group. So if you select to draw the lines between the same group, lines are drawn only between the points that belong to the same group. Say here this object belongs to group 2, so lines are drawn only between those points. And the path object belongs to group 1, so lines are drawn only in between the points that belong to group 1, that is the path object. Now you can also have lines drawn between different groups. That means lines are only drawn between points that belong to different groups. Here, as you can see, these points belong to the same group, but they're not. The lines are not drawn between them. But these points and these points, they belong to two different groups, so the lines are drawn between them. This can be useful if you have different objects and if you want lines only to be drawn between different objects. So that's how the draw lines actually works. Now you can also show only lines that are connected. Say if you select this, all the points which are not connected to a line are not drawn. As you can see, these points are not connected to a line, so when you select this, these points are not shown. So that's how it actually works. And another important thing I didn't mention is the number of points to search. It's in the lines thing, it's here. The maximum number of points to search. That means every point searches for these many number of closest points to draw the lines. Say if you put it to 1, only like each point looks for only 1 point, so the number of lines drawn are low. If you increase the maximum number of points to search, more number of lines are drawn. And say if the points are much closer, like in this case, let me put it to all groups. So when you increase this, more number of lines are drawn between the points, and when you decrease this, less number of lines are drawn between the points. So that's how basic rendering works in Plexus.